Hello everyone. In this video we're going to be proving an inequality. Not just an ordinary inequality, but a trigonometric inequality. Proving inequalities is fun, and proving trigonometric inequalities is even more fun. So we have 1 over sine squared x plus 1 over cosine squared x is greater than or equal to 4. That's what we're supposed to prove. Sine squared x means sine x quantity squared. So we can write sine squared x as sine x to the second power. And the same thing goes for cosine squared x. Now, we're going to be using some properties, laws, rules, formulas. So let me go ahead and write them out. So we're going to be using the fact that sine squared x plus cosine squared x is equal to 1. We're going to use the fact that sine squared x is between 0 and 1, because sine x is between -1 and +1. If you square that, it's going to become non-negative. And we're also going to be using the formula for sine 2x, which can be written as 2 sine x cosine x. So those are the tools that I'm going to be using to prove this inequality. So let's go ahead and take a look at it. I'm going to make a common denominator on the left-hand side. Let's go ahead and make that. Multiply by cosine squared, and then by sine squared, and then divided by the product, which is the common denominator. And we're supposed to prove that this is greater than or equal to 4, but at this point I don't know if it's true, so I'm not going to write anything on the right-hand side. So this expression can be simplified because cosine squared x plus sine squared x, as you know, is equal to 1. So I can replace it with 1. And this is what I'm getting. So this is my expression. Of course, in this case, I have to be careful. Sine x should not equal 0. Cosine x should not equal 0. So those values are excluded. Okay. Now, how am I going to use sine of 2x here? I do have the product 2 sine x cosine x, but this is squared. So let's go ahead and square sine 2x. What do you get if you square sine 2x? You get 4 sine squared x cosine squared x. My expression doesn't have a 4 in it, but I can easily make one. So let's go ahead and multiply the top and the bottom by 4 so that we get the following. 4 over sine squared 2x. And if you want to call 2x alpha, that's okay, but doesn't really matter. Now, we said that sine squared x is always between 0 and 1. Of course, I have to make sure that sine x does not equal 0, so I'm going to exclude 0 from here. So in this case, I can safely say that if sine x or sine 2x, if sine 2x does not equal 0, then sine squared 2x is going to be between 0 and 1. 0 is not going to be included because sine 2x does not equal 0. And now we're going to flip this. We're going to turn this upside down. Now, you have an expression that is positive. It's always going to be positive. But if it's less than or equal to 1, when you flip it, think about it like a fraction, like 1/2, it is always going to be greater than or equal to 1. Great. Obviously, this is always positive, so it's all good. And if something is greater than 1, obviously, that's positive. So now, we can multiply the top and the bottom by 4. Actually, not the top and the bottom. I meant multiply both sides by 4. Okay. If you multiply both sides by 4, then you're going to get 4 over sine squared 2x is greater than or equal to 4. And this basically proves the inequality that we were trying to prove, right? It is greater than or equal to 4. But what happens if sine x is equal to 0? Then our expression is going to be undefined. Of course, in order for this to equal 4, sine squared 2x needs to equal 1. And this means that sine 2x is equal to 1, or sine 2x is equal to -1. In this case, in these cases, we just have to be careful that sine x or cosine x does not equal 0. Now, here's another thing to consider. Is we said, okay, we kind of showed that this expression is greater than or equal to 4, but is 4 attainable? Let's go ahead and talk about that. So let's write our original problem. It was 1 over sine squared x plus 1 over cosine squared x. Now, if sine x and cosine x, usually with proof of inequalities, if the values are equal to each other, that's when we usually get the equality, most of the time. I should say, because of the symmetry. So here, if sine x equals cosine x, and they're both equal to plus minus square root of 2 over 2, then their squares is going to be equal, of course, and that is going to imply that they're both equal to 1/2. And then when you flip the 1/2, 1 over 1/2 plus 1 over 1/2 is going to be 2 plus 2, and that is going to show us that the value of 4 is actually attainable. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.